Hello everyone, I'm Hyunyoung Kim, a PhD student at Seoul National University. In this video, I'm going to summarize the result of 10th AGORA paper, Formation and Evolution of Higher Redshift Galaxies. The AGORA project is a code comparison project designed to improve the predictive power of galaxy formation simulations. From the identical initial condition and common physics, we run simulation using different numerical code with their own subgroup physics, such as supernova feedback and metal diffusion. This approach allows us to test the robustness and the consistency of cosmological simulation code. In this paper, we introduced the AGORA Hydron, which extends from the AGORA Cosmolon simulations. Cosmolon is a zoom-in cosmological simulation of Milky Way mass halos. From Cosmolon, we have published 6 papers analyzing the property of Milky Way-like galaxies, their satellite, and the circumgalactic medium. Now, we extend our focus to the higher redshift universe. Higher redshift galaxies from JWST observations are brighter and more massive than predicted at early universe. In this work, we test whether the cosmological physics, which were calibrated at low redshift, can reproduce these higher redshift galaxies. We also check the various properties of galaxies above redshift 10. For the initial conditions, we selected 5 massive halos in a 64 co-moving megaparsec box. Their mass evolution is shown in the table below. So far, 6 simulation codes have participated, and the ART1 code will be added soon. We first look at the stellar mass evolution of the Hydron. Although there are differences among codes due to different stellar feedback, codes generally shows good convergence across all halos. When compared with data with this spectroscopic data, the observation shows a trend towards better agreement for more massive halos. We also analyze the metallicity evolution. Just like stellar mass, metallicity shows a similar trend that massive halos align well with observation. However, the variation of code is much larger. This is because each code treats not only supernova feedback but also metal diffusion differently. For example, Gaza 3 shows the metallicity flow at redshift around 14 since it doesn't explicitly include metal diffusions. Since the most massive halo shows the best agreement with observations, we analyze its star formation rate and efficiency. The left panel shows the star formation rate averaged over 3 million years. All codes show the fluctuations, indicating burst formation happen in the higher redshift environment. On the right, we plot the star formation efficiency defined as the star formation rate divided by the halo mass growth rate and the baryon fractions. Overall, code shows the higher efficiency than the local efficiency of 1% used in the simulations. Some code, like Gizmo and Gadget, even reaches several tens of percent, suggesting stellar feedback might be inefficient at higher redshift. Using the radiance per code score, we generate more observation data from our simulations. In this figure, the first and second row shows the mock image of halo 5 without and with dust, and the third row shows the dust density distributions. Depending on the dust structures, the light is attenuated differently. For example, Gadget 4 has a very dense dust at the centers, which reduces the luminosity significantly. However, in Ramses, which lack the dust in the center, shows little attenuations. Finally, we explore how dust affects the galaxy luminosity by changing the dust-to-metal ratio from 0 to 0.4. At higher redshift, the difference is negligible because dust projection is still low, but after redshift 12, the luminosity begins to diverge depending on the dust-to-metal ratios. Interestingly, the difference between the dust-free and dust-included model is much larger than differences among the dust included models themselves. In summary, I have presented the main result of AGORA project paper 10. It is now available on arXiv, so please take a look if you are interested in it. Also, the Agora project continues. Our next project is about the dwarf galaxies. So please stay tuned and keep an eye on the Agora. Thank you for listening.